Hi everyone. In order to talk about chemical bonding, specifically covalent bonds, we need to talk about electrons. And we need to talk about electron energy specifically. Electrons can absorb and release energy. So if you're in the parking lot, you'll notice that the parking lot gets hot in the noonday sun. What's happening is the molecules in the asphalt are absorbing energy. The energized electrons are moving from level 1 to level 2 to level 3. Those are quantum levels or energy levels. And so what happens is the sun's light energizes the electrons. The electrons are unstable at the higher level and return to the lower level, releasing energy. Here's a diagram of that showing energy absorbed, moving electrons from a lower level to a higher level. And then when the electrons come back down in energy levels, they release energy. So do you notice anything about this diagram? How about this? Okay, the first row, you'll notice the hydrogen atom has one electron. It has atomic number 1, 1 proton, 1 electron. That electron is in the first shell. If we move to the other side of the chart, still on the first row, we see helium. Helium atomic number 2, number of protons, 2, number of electrons, 2, position, all in the first shell. But now we move to lithium, atomic number 3, and that's in the next row, because lithium, atomic number 3, has how many protons? Yes. And how many electrons? Yes, 3. And those electrons are 2 in the first shell, 1 in the second shell. And as we go across, we see oxygen has atomic number 8. It has how many protons? 8. It has how many electrons? 8. It has how many in the first shell? 2. It must have then how many in the second shell? 6. 2, 4, 6. If we go all the way to the end of that row, we see neon. Neon has atomic number of 10. How many protons? 10. How many electrons? 10. How many in the first shell? 2. How many in the second shell? 8. That shell is filled. We go to sodium, which is the very next atomic number 11, but we have to go to the next row because we're filled with 8. So now we're following from here on out the octet rule, which says that every atom is trying to fill its outer shell with 8 electrons. The only exception is obviously hydrogen. So let's move to chemical bonds. So atoms combine to form molecules. Here's the atoms. And why do they combine to form molecules? Because they're trying to fill their outer shells. Hydrogen, if we look at hydrogen, it has 1 proton, 1 electron, first shell electron. What does it need to fulfill that first shell electron? It needs 1 more electron. If it had 2 electrons, it would be filled with, like helium, and it would be happy. It's not happy. So here's what happens. So 2 hydrogen atoms spot each other. They come together, and the electrons get shared in the middle, and the 2 protons get attracted to this negative electron sharing zone. The hydrogen on the left has 1 electron, the one on the right 1 electron. If they're sharing electrons, they're coming together. So now we have a hydrogen molecule with 2 hydrogen atoms. Another way of looking at it is this. So first we look at what's the molecular formula for hydrogen gas, and we find that it's H2, so that means it must have 2 atoms of hydrogen in the molecule of hydrogen gas. So we diagram the atoms on the left side. Then we mash them together so that the electrons appear to be shared. And those shared electrons create a negative field in this region, pulling in the positive proton on either side, creating a bond that we call a covalent bond, represented by this red line in the structural formula. So now if we were to do the same thing with oxygen gas, we would first ask, what's the molecular formula for oxygen gas? And Siri would tell us O2. So we diagram 2 oxygen atoms on the left side. Then we mash them together to create something that will fulfill the outer shell desire to have 8 electrons. So if we go around the outer shell now, we can see and count the electrons. We can see 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outer shell of this oxygen, making it happy. If we go around the outer shell of this particular oxygen atom, we see 1, 2, 3, 4, 5, 6, 7, 8 electrons. That's also happy. But how many electrons is it sharing now? How many pairs of electrons is it sharing? So we give that a double covalent bond because each red line represents one pair of shared electrons. So oxygen is 2 atoms of oxygen, or held together by a double covalent bond. This video is going to end, and the next assignment is asking you to do nitrogen gas molecule, a methane molecule, and a water molecule. And so what you're going to want to do is exactly the same format as you see up here. The first thing you're going to ask for the nitrogen gas is you're going to ask Siri, what is the molecular formula for nitrogen gas? And then you're going to, whatever that is, then you're going to diagram the number of atoms in a molecule of nitrogen gas. Then you're going to mash them together to make every outer shell of each atom happy. Then you're going to create the structural formula. Then simply do the same thing for a methane molecule and a water molecule.